Hello everyone. In this video I would like to go over the feature of using incentives when creating jobs in PioSolver. If you're not familiar what the jobs are or what incentives are, I did cover that in my previous videos, so now I will assume that you're familiar with both. Okay, so let's see how it goes. So just a quick reminder anyways, if we can build a tree from some configuration, we can navigate to some place in the tree and apply incentives. So for example, let's say that we want to, so we have this 3-bet pot and we want to have a out of position player slightly over betting on the flop and slightly over betting on the turn. For that, we have to go to the root and then select 3 adjust incentives in current line. And then we can add some incentive to the first player. And then when we resolve the tree, the player will bet slightly more than in the regular equilibrium. After we do that, we can stop the calculation. We can go now to the turn and lock and incentivize bet on the turn by again going to adjust incentives here and specifying some number here. And also what we want to do before we resolve again with the turn incentives, we will want to lock all parents of this node. So now, how do we do that? How do we achieve the same effect when scheduling a job? So we have to select the configuration that we're interested in. I will put it here, maybe make this window slightly smaller. So we go here and we generate some number of boards we want, and then we will be working in this window solver commands to execute before solving. So first of all, basically we will do here 3 things. So I will type just something. So set incentives on the flop, solve the tree, lock flop node, set incentives on the turn, and solve the tree again. So how to do that? So we will go again to the root node and again set adjust incentives in node. We will again set those incentives here, and then we will click this little thing, copy command to clipboard. We will select that and we'll type it here. So this will tell solver that before running the tree it should execute the command set incentives in line R0, and the incentives value are 10 and 0. And now comes a little trick here. So this is new. We have to type a word solve in here, which is a new command that is not a real solver command. So the viewer, when executing a job, will understand that whenever we type a word solve in here, it means solve to the desired accuracy and timeout. And we can also give some label here, like solve flop incentives. And then we have to lock the flop node. So now we will go to the turn. So we will go here, against adjust incentives, and we will lock all parents. But before clicking OK, we will copy node lock command to the clipboard. Okay. Do you want to continue? Yes. So now we can type this command here, which is lock node R0. And another thing is that in this line, so root, bet call, and the turn card, we want to set these incentives in the script as well. So we will say set incentives in line and copy this to clipboard. And let's say set incentives in line, and here we have a node ID. And you may notice this little thing in here, which is a question mark. So normally if you would get this node ID from the tree, this node ID is basically R0, which is the root node, bet94 call 4 of clubs. But in the script, when we're using the set incentives line feature, the particular card may not exist on our boards. So if we choose, for example, King of Spades, then okay, King of Spades turn exists on this board, but does not exist on this one. So therefore, we have introduced this placeholder with question mark in here. So this is done. We have set incentives line on the turn, and we can say here again, solve turn incentives. So the last solve is optional. So if we don't write solve by the end of these commands, it will solve anyways. But this can come handy. So I will set here some absolutely unreasonably high accuracy, just so that my script completes very quickly. I will call this job 3-bet pot fast incentives, and I will name the file script incentive board, and I will enqueue this for execution. And now we have this job in here. So when we run this job, we will see the command saying start solving flop incentives. Then when the required accuracy is reached, we will have start solving turn incentives, and then first tree is done. So I will cancel that because I don't want to compute I don't want to compute all of those files right now. But we can search on my disk like this file that we have just computed, which is this one, and we will just go here and verify that indeed it looks how we wanted it to look like. So yeah, in the root node we have bet that is high bet frequency, but it doesn't really matter because we did not compute to the high accuracy. But we see here that it's locked and that the incentive is set. And then if we go bet call to any of the turn nodes, we also hear that the incentives are applied in here. So that's pretty much about this feature. So I hope it is useful. And that's it. Thank you for watching.